Why though?
That's the only time that it's 0.
What's that?
Because you can only really go to 0 pi or whatever.
Mm-hmm.
But you can't go around to make it 2 pi, so it's like you're just stuck in it.
Why are you stuck? I don't understand why you're stuck.
Because of the exclusion zone.
I think y'all are leaving out what I want you to not leave out, which is the obvious thing. The angle is 0, yes? Okay. I don't think this is working out the way I was hoping. I guess this is what I was trying to get, and maybe it's too much. I was trying to get you to say, okay, so when I see this, I'm thinking to myself, where on the unit circle is the y-coordinate 0? Then I say, what is the angle that corresponds to that, right? And make sure that I'm not looking over here. And that's it. That's what you're doing for each of these. All right? Now this one was a little bit, I guess, the y-coordinate is 0 here, so your angle is 0. You can't go all the way around to 2 pi. You have to just be at 0, so you're done. How about this one? Arc sine of negative root 3 over 2. Anyone want to try and say that? Like the way I'm kind of saying it over there? Does my way make any sense? I mean, am I making sense when I'm saying this? I hope I am. I'm trying to do this for a living. So is it making sense to you the way I'm trying to get you to see it? Negative pi over 6. And I heard 5 pi over 3 also. Okay, so why is it negative pi over 6, you think? What did you do? You drew a circle, okay, and then what did you try and determine from there? Where's what negative? No, come on, it's there. Where's what?
Like, where's it on the circle? Like,
This, x or y? The y, right? Why the y? Why the y though? Because it's sine, right? Now that's important because we're about to do cosine. When we do cosine, we're going to look at the x-coordinate. So it's going to be different, right? So I'm saying where on the unit circle is the y-coordinate negative root 3 over 2, but I'm not allowed to look over here. Do you remember I said you really need to understand the unit circle? Yes.
Why are we not allowed to look over there again?
Do you remember how I cut the sine function? We said we could look at it here, we could look at it here, and we just have to all agree where? Okay, when we cut it, we said you had to be between negative pi over 2 and pi over 2. And if you look at this angle, this is 0, right? This is pi over 2. I can't go past that. And then negative pi over 2 is this way, and I can't go past that. So I'm always stuck in the first and fourth quadrant when I'm dealing with arc sine. But don't get too married to that, because when we do cosine, it's not going to be the same. We good? So we're saying, did you change your answer? You change your answer?
I thought it was like an x coordinate, so I would like.
You went out here, but you were looking at the y-coordinate, maybe? Or the x-coordinate?
Yes, the x.
Okay. All right, so we want the y-coordinate to be negative root 3 over 2. We have to be in one of those quadrants. So it's this one here. This right here. Can't be 5 pi over 3. Why not?
Oh, I'm sorry. When we create a circle, it's going to be negative pi.
There you go. It's got to be negative pi over 3. So you're going to rotate this way by pi over 3. So negative pi over 3. Everybody clear on this? Any questions? If somebody has their calculator, type in, you have this function on your calculator. See if you can type this into your calculator and see what it gives you. Did someone raise their hand?
Oh,
Yes.
so anytime it's sine inverse, we always are going to black out the left part.
That's right. Anytime we're looking at arc sine, you always black out the second and third quadrants.
Yep.
You should get a decimal, unless you got a fancy calculator.
I had mine set to degrees, and it gives you, that's the right angle either way, 60.
Yeah. Oh, so it gave you 60 degrees? So if you're in
Degrees.
it gave you negative 60 though, right?
No, but no, exactly.
Oh, you forgot the negative here.
Yeah, but
Okay.
it would have been
Yeah.
negative. It gave me 60.
What I was trying to get at is that if you're in radian mode on your calculator, your answer on your calculator is not going to say negative pi over 3. It's going to be the decimal. It's going to be negative like 3.14 divided by 3, so it's going to be like negative 1 point something.
Negative 1.047197555.
Yeah, and this is the answer I want. I don't want decimals. I don't want calculators for this. Trust me, when you're in calculus, you don't want to be that person pulling out their calculator trying to do arc sine of 0. You don't want to be that person. Everyone will just be looking at you like, okay, right? Understand what's going on here. It's the y coordinate off the unit circle restricted to the first and fourth quadrants. Determine the angle. All right, we're going to move on to cosine, but I just need a little bit more with sine. Do you remember this? I just wrote this on the board earlier. I'm just going to sketch it up here real quick again. That we said that for two functions to be inverses, then when we put them together, they basically undo each other. I did it with f and g. But that's the basic property of two inverses, that if you plug f in, if you plug x in, you send it through the inverse, then back through the function, it comes out unchanged. And if you send it through the function, then its inverse, it comes out unchanged. So they undo each other, right? Now, in terms of sine, in arc sine, how would this look? It would mean that if I take sine of arc sine of x, what should come out? X. And if I take arc sine of x, it should spit out x. That's what that's saying. This is very dangerous, all right, we need to talk about this. This is actually called the cancellation properties. Is that two L's? That doesn't look right. I think it's 1L. Where's my English major in here? Okay. That's true. Who cares? It's two L's? Oh, okay, good. I don't care if it's one or two. Everyone understands what I mean, right? Cancellation. All right, so that's just basically saying they cancel each other. This is extremely dangerous. This is one of the first things I give in a Cal 2 quiz, is this right here, just to see if the people coming to me actually understand what they're doing or not. All right, so let me try something, okay? Let me give you this. Arc sine of 5 pi over 3. If you just blindly take that property I just gave you, what are you going to tell me the answer is? You're going to tell me 5 pi over 3. And I'm going to tell you you're wrong. Why am I going to tell you you're wrong? According to the property, it should just cancel out, right? Now, I've left some stuff out on these properties. There's some, like, you know how they like to put those little asterisks when you're reading something? It's like read the fine print. There's fine print on this shit right here, okay? So we need to understand that we're going to have to clarify that in a second. I don't want you to take it as it is. This is why. Look at this right here. What is sine of 5 pi over 6? That's the y coordinate at the angle 5 pi over 6 on the unit circle, right? So here, go here, or did I say 6? Sorry, 5 pi over 3. So where's 5 pi over 3? Isn't that down here? That's where it's the y coordinate there. What's the y coordinate there? Negative root 3 over 2, right? Yes? Okay, so this should be sine inverse of negative root 3 over 2. That's what this should be, right? What is arc sine of negative root 3 over 2? We just did that. What was the answer? Negative pi over 3. See, this by itself spits out negative root 3 over 2, And when you plug that in here, the arc sine says, hey, look, my answer can only come between these two angles. I cannot go around. So it's going to spit out the negative pi over 3 instead of the 5 pi over 3. So the cancellation property actually does not work always. There are some issues. Do y'all get it? So even though these are good properties, I always encourage my students to just work them out. Like, did that take that long for me to do that? Like, what's the y coordinate here? No, and then the next part? Not that big of a deal, right? Now, when is this true? I'll put the fine print here. Arc sine on there. Okay, I got to take a quick, I've got 3. All right, so there are some times when this is true, all right? There are some times when this is true. So here's the fine print. The first fine print, the top one, is that this is true, this one is true, so long as the x is between -1 and 1. And this one is true so long as the x is between -pi over 2 and pi over 2. I'll try and help you understand why the fine print's there a little bit. You see this right here? This was like this one, wasn't it? The x we were plugging in was 5 pi over 3. 5 pi over 3 does not live here. So it's not just going to spit out that answer. Now, can we still do that? Yes, we did it, right? But this property is not going to work. Let me illustrate that with another example right below it. What's arc sine of sine of pi over 6? Well, is pi over 6 in between pi over 2 and -pi over 2? Is it in here? Yes, then it's going to spit out pi over 6. See, that right there, well, sine of pi over 6 is 1/2, but then arc sine takes it back, right? So if this angle right here that's going in is in these first two, right? But what I mean is between -pi over 2 and pi over 2, if it's in there, then the property works. If not, you have to actually just figure out what the y coordinate is and then undo it again. All right. How about this one? How about sine of arc sine of 1/2? What is that? That's a half. Are you using the property over there? Yes, you can use this property. So now I'm using this one. The arc sine's on the inside. This formula will always work so long as the thing you're plugging in is between -1 and 1. So as long as this is between -1 and 1, it's just going to spit out 1/2. What is this? Can I use that over there? I can't use that because the thing I'm trying to plug in is not between negative 1 and 1. What do you think? So let's go back to what this means, all right? So let's cover this up. This means I need to go to my unit circle. I need to look on it for a y-coordinate of 2. And it's not there because it's a unit circle, right? The unit circle has radius of 1. This is not ever going to happen. This is actually undefined. This is undefined. This is basically equivalent to me saying, hey, where's the sine function equal to 2? But the amplitude is between negative 1 and 1, so it never reaches 2. So it's undefined. All right. Do you want to move on to cosine? We still have some time. Now, when we graph the cosine function, we have to make a choice of where to cut it again. Arc cosine. Now here's our standard picture of cosine. So we need to try and find a cut that's going to get us our entire range. That means everything between negative 1 and 1. So where's one place I could cut it? I could go pi to 2 pi, heard that, right? Pi to 2 pi would get me the whole thing. I also heard what?
0 to pi.
0 to pi. And then there's a bunch of others I could use, right? Well, the one that we all agree on is 0 to pi. That's where we make the cut. Right there, that is a function that has an inverse, right? Passes vertical and horizontal line test.
So what quadrants are we going to be on? Same quadrants on the unit circle with cosines?
Our restrictions are going to be different now because the arc cosine
0 to pi.
is written this way, arc cosine of x, or arc cosine x, and it's only valid for x between 0 and pi. Only between 0 and pi, which is actually which quadrants of our circle? The top half, so 1 and 2. So before we were looking between like quadrants 1 and 4, and we were looking sine over there. Now the bottom two are the off limits place. I've always found that arc cosine's a little bit easier to deal with than arc sine. Now without actually getting into any more, I think we can just go into some examples. I hope this isn't throwing you in too fast here. What about arc cosine of root 2 over 2? Pi over 4. So you're saying to yourself, where on the unit circle is the x-coordinate, right? Now we're talking cosine. Where is the x-coordinate, root 2 over 2? That happens here. There's actually two places it happens, right? Here and here. However, I'm not allowed to be down there. I can't be down here. 0 to pi is the only place I can be. So that angle, right, this is root 2 over 2. Who cares about the next one, right? I'm not even looking at this one. I'm looking at the x-coordinate. So this is pi over 4. How about arc cosine of 1?
Zero.
0. because you're saying at what angle is the x-coordinate 1? And the x-coordinate's 1 when you're straight out, right? And so the angle is 0. 0 degrees. Or 0 radians, however you want to say it. Have you noticed that everything I've done has been in radians? I've done nothing in degrees. And that is really because, like I've told you, I do mostly like calculus. When I teach most of the calculus, we never, I mean, I don't want to say never. I'd say like 98% of the time we're in radians. So it's just more natural to start getting used to it now. All right, how about, what's our cosine of 0? Pi over 2. So that's saying where on the unit circle is your x-coordinate 0, but you can only be in the top half of the unit circle, so pi over 2. Now there's a cancellation property for the cosine, our cosine also. So let me show you that property. We have that cosine of cosine inverse of x should be x. And we have that arc cosine of cosine of x should also be x. What do you think the restrictions are here for these to be true? What about for this first one? Remember, the arc cosine, this thing in here is the x-coordinate. So what do you think the restriction on the x-coordinate that I put in can be? -1 to 1. So that's only valid if that's true. And then this is only valid when? 0 to pi. So these are our cancellation properties for cosine. I'd like to give you an example of the cancellation property for cosine. Cosine inverse of cosine of 7 pi over 6.
Never mind.
Oh, it's earbuds. I was like, what the heck is that? All right. Is this just cancellation property? Boom, it's just 7 pi over 6? No. Because 7 pi over 6 is not between 0 and pi. So let's do this piece by piece. What is cosine of 7 pi over 6? Root 3 over 2. So you're going here. You're going to 7 pi over 6, which is right here. And you're looking at which coordinate? The x-coordinate, which should be -√3 over 2. Okay, so this is saying what is cosine inverse of -√3 over 2. Now you're saying where on the unit circle is your x-coordinate -√3 over 2? But you can't be down here. So that's got to be here, right? What's that angle? 5 pi over 6. So you see how that can be a little tricky on that. Any questions on that? You okay? You're just going to have to get into the homework and mess with these a little bit before you start to feel real comfortable. I'm going to do a quick summary, just a real quick summary. See if you can help me out here. When we're talking about the sine function, what's its domain?
Negative pi over 2 to pi over 2.
Yes, yeah, what I want you to do is right now be thinking about when we restrict things with the arc sine, like what is our domain restriction going to be? So we're going to have to restrict it negative pi over 2, right, to pi over 2. Let me do it with an interval. I like that better. Negative pi over 2 to pi over 2. What's the range of the sine function going to be?
1 to negative 1.
Negative 1 to 1, right? All right. What about the arc sine now? Switches, we switch, right? Negative 1 to 1 is the domain, and the range is negative pi over 2 to pi over 2, right? They switch places. That's what I was saying earlier. Now let's do cosine and arc cosine. So for cosine, we're going to restrict it to what?
0 to pi.
0 to pi. Now the range is what?
1 to 1. So
Negative 1 to 1, right? The arc cosine, switch them. It's going to go negative 1 to 1, and the range will be 0 to pi. Now, what do we still have to talk about today? Tangent. So I'm going to put tangent in here. I'm about to put tangent in this table. I'm going to show you the picture of it, because we have to cut it somewhere. This was our tangent. It had vertical asymptotes at pi over 2 and negative pi over 2. And I told you, please remember those, because they're going to become important next class. And today is next class. So remember that picture, right? And then it kept on doing it on both sides. So where do you think we would make our natural cut here to create a function that has an inverse? Negative pi over 2 to pi over 2. What we're going to do is take all the other junk out and just look between here and here. Because between here and here, doesn't it achieve its entire range? It does, right? And it'll pass the vertical and horizontal line test just between these two. So if that's where I cut it, what's my domain? Be careful. Negative pi over 2 to pi over 2. How do I write that here? Does not include. So what do I need to put? Parenthesis, negative pi over 2 to pi over 2 parenthesis. Understand? Because they're vertical asymptotes there, I cannot include those points. Now what about the range? Negative infinity to infinity. I just put a bracket on negative infinity. That's pretty good. That's pretty funny. All right, negative infinity to infinity. All right. Negative infinity to infinity. Do y'all see the range? It's everything? That's interesting, because that means the arc tangent is going to have a domain of everything, right? All real numbers. So arc tangent is going to have as its domain negative infinity to infinity. And as its range, what? Negative pi over 2 to pi over 2. Which is interesting. You can plug in, to tangent, you can plug in angles between negative pi over 2 and pi over 2. And it's going to spit out numbers that range from negative infinity to infinity. Now, the inverse of that, or the inverse function, it will take on any number. You can feed it any number. And it's going to spit out numbers, but they're going to only be spit out between here and here. So, interesting. Maybe we should try one of these arc tangents. I think we should. Let's do an example of an arc tangent. This is the notation for arc tangent. What is arc tangent of 1? Now this is different, because with arc sine, you were saying, okay, I'm going to go to the unit circle, right? And I'm going to look at the y-coordinate. And with arc cosine, you were saying, okay, I'm going to go to the unit circle, and I'm going to look at the x-coordinate. With arc tangent, you're going to say, I'm going to go to the unit circle, and I'm going to look at the y divided by the x. So I need to figure out where my y divided by x equals 1, where the ratio is 1. Pi over 4, right? Now, is that the only place it was 1? This was root 2 over 2, root 2 over 2. So the ratio of those two is 1, y divided by x. But it also happened down here, didn't it? But I can't be there. Why can't I be there? The restriction for arctangent is that I'm between, right? I've got to be between negative pi over 2 and pi over 2. So it's the same sort of restriction that we had for arc sine, right? Arc sine, we could only be in the first and fourth quadrants. Arc tangent's the same sort of restriction. Now, it's not exactly the same because you can't include the endpoints. You cannot include the endpoints here. Here you can. Here you can't. So the answer, sorry, I didn't give the answer. It was pi over 4, right? Now, these get a little harder to do. Let's do another one. What would arctangent of the square root of 3 be? You need the ratio of the y-coordinate over the x-coordinate to be root 3. Pi over 3. Pi over 6. What is it? Okay, I can only play over here, right? I need the ratio of the y-coordinate over the x-coordinate to be this number. Can I be down here? No, these are negatives, right? Look, if I'm over here, my y-coordinate's negative and my x-coordinate's positive, which means that the ratio can't be positive root 3. So I have to be up here. So let's just look at our common angles here. 30, 69, or 30, 45, 60. Look at this one. This one is root 3 over 2, 1/2. This one up here is 1/2 root 3 over 2. And this one has root 2 over 2, root 2. I know it's not that one, right? So they both have root 3's in them, so it's pretty promising, isn't it? So y divided by x. Why is it y divided by x? Because that's the definition of tangent, sine over cosine. So let's try it. Let's take this over this. Just do it real quick. Root 3 over 2 over 1/2. It reciprocates up. Root 3 over 2 times 2 over 1. That's root 3. So it's this one, which was that angle, which was pi over 3. Okay? This one right here, pi over 3.
Like, so could you put tangent and then parentheses radical third? Do you mean to put -1 for the arc tangent?
Oh, I did forget that. Thank you so much. Glad you caught that. I forgot to put the arc tangent symbol here. Tangent of root 3 would not be pi over 3. I feel good. Y'all feel good? You have some homework. I'm not done with this section. There's a little bit more. I want you to, do your best on the homework. I recommend, honestly, that you do more than I ask. Just keep trying as many of these because really, this is forcing you to get that unit circle down. It's really forcing you to get it down, and you'll be rewarded later for having that. You'll be rewarded in your future math classes if you've got the unit circle down. I'm going to pass around the sign-in sheet. And I'm sorry? Yeah, go ahead. I have not taken this in a while. Oh no, I have. Let's start this in the. I think it's just there, yeah. Start it back here.